Hey everybody, just wanted to get on here and explain to everyone what I've been working on the last few months really. It's a new plate system that from the outside it looks basically the same, but the goal of this system is to improve user experience, make it a little bit easier for everyone to change out their magnet setups, and it's going to, I think it really improves the overall quality of the product. So yeah, it's a pretty big change in the Rapt. Like I said, not huge from an exterior standpoint, but it does make some really great improvements otherwise. So we'll hop over to the bench and I'll show you what I'm talking about. Hey, here we are at the bench. So new parts. This is the same setups that you know and love. Different inserts, different plates. What else is different? Everything else is the same, and that's the cool thing about it. That's what I really am feeling really great about, is that everything else is the same. You do have a new optional screw, which actually will be required in some instances, and we'll get to that. But for the most part, it's a new plate. This is the new plate. As I said, as I mentioned, it's outwardly, it doesn't look any different. The one aesthetic difference between the V2 and this is going to be called the V3 is there's a counter bore around the screw, and on the V3 there is no counter bore. It's just a sunken countersunk area that will hold the screw, and the screw does sit below the surface, the sliding surface of the plate. Whereas in the counter bore, it was sunken just a little bit deeper. Had to make some concessions to get that screw to align differently, and move the screw up in the assembled condition. I'll show you what I'm talking about. So, new plate. These are the new inserts. Some bodies here. Move those out of the way. Here's the new inserts. They are a single piece insert design that are basically identical to the Rapt Lite inserts. The magnet spacing is the same, or very, very close to the same. But the big change is that it is a single piece insert. Also the fitment of the insert, there is very, very little movement of the insert. Depending on which way you flip it, there's hardly any movement. Flip that way. And that has to do with the kerf. There's a little bit of a draft angle. So one way it'll fit a little tighter than the other. Yeah, there's the hybrid insert. This is the 2x3 medium insert. We've got, that's our hybrid. Here's a 2x4 medium insert. We've got a 2x4 strong insert. So all the insert magnet layouts that you're used to. But the big change, the big thing that's different with these plates versus previous plates, this is just a meat hammer body that I had laying around. If you assemble the slider, if you'll notice, there's a bit of a gap between where the plate sits against the internal post of the body. There's a gap in between there. And the function of that is to allow the screw pressure to suck the plate in until it contacts the body. So it's actually improving the amount of clearance in the center of the slider. And the most important function of this is compression. So it takes a few revolutions for it to seat down fully. Like I said, the main function of this is to offer compression. So you can see that the middle of the plate is going to be sunken down an additional 10 thousandths which is it's a pretty good bit in machining terms. An additional 10 thousandths of depth in the center versus what you're used to. Also, the other big thing about this is that it will very uniformly compress the foam material or whatever dampener material you would like to use. It'll uniformly compress that material. There have been complaints about some clickiness no matter what you do. Some people use tape on their magnets to keep it from clicking. But yeah, clickiness in general from the Rapt product, going on for a while now, and people usually compensate either using blue tack or using tape or whatever they have laying around. With this configuration, you can literally use whatever you want to dampen your magnet movement. But I've designed these foam dampers that actually fit snugly against the interior post of the Rapt. And they are lined. You can line them up. You get them, kind of close. And now you don't have to fiddle with settling your dampers on top of your inserts when you go to assemble it. Just simply put it in there, align it, throw it on top, you're good to go. So there's the 2x3 version. I've got a 2x4 version. Like I said, they fit this post snugly so that you can clock it, orient it, push it down, straighten it out. And then as you can see, the little wear patterns from where the magnets have been, it hits those magnet centers perfectly. So yeah, let's put one together right quick with a V3. There's going to be no increase in cost associated with this, with the plastic inserts. I would expect a certain percentage of increase when I do inserts, but we'll see. We'll see. I have not priced any out yet, but the main thing is the acrylic inserts. There is no additional cost associated with that. Let's do a hybrid setup. That's the most popular setup. I mentioned there's a draft angle when these are laser cut, so one side is going to be a little wider than the other. I believe that this is the wider side. So as you can see, no magnet wiggle or insert wiggle whatsoever. Whoa, I threw it. No insert wiggle. All right, let's put this one down, wide side down, no insert wiggle. Let's compare, let's grab another V3 plate here. And let's grab a V2 insert. Let's see, I have some hybrids right here. So the V3 insert, plate, you can still use a V2 insert set with the V3. As you can see, there's a bit more wiggle, which you're used to that with a V2 anyhow. But you can see how the magnets would easily migrate from their positions using these inserts. With the one-piece insert and the little diamond in the middle, everything clocks and fixes itself well. There's a V2 plate with the V2 inserts. As you can see, wiggle still. Let's flip it over to the wider side, still wiggle, right? Versus V3. Maybe a few thousandths of wiggle there. So greatly improved in that way. All right, let's load it up with some magnets. This is the way that I assemble every single Rapt slider when it's new. And go ahead and do one whole side. After I'm done with that side, I take my magnet stack and just flip it over. That way I know that the magnetic fields are opposing one another. It does help to have a couple extra magnets to be able to move that last magnet over into its position, and you have something to slide off the top there. All right, let's see. I have this set of bronze bodies here. I had completed these just a few minutes ago. That's actually the sign-up sale item for today. I'll have 10 of these this weekend. Let's see, that's the 2x3. Let's do the 2x4. 2x4 damper, roughly aligned. Just take that, throw it on top. Another 2x4 damper, aligned roughly. There we go. And throw it on top. Grab a couple screws. Misaligned it. There we go. Had to push it together a little bit. Nice and tight. You can feel when these get tight also. There's a little bit better feel when you're assembling it with these. And again, the overall, like the resulting, the results of this change is increased quality. No magnet rattle that way. Still the same product you know and love. Just a incremental change, which is actually a fairly big change, but an incremental change that is aimed at saving you time, not costing you any more money, and overall improving the quality of the product. So let's see, you can see the gap there. You can see that the middle of the plate is uniformly sunken. There's also the issue where V2 plates would go out of tune, meaning that they would develop a crown to where the ends did not go up into the slider uniformly. And then the fix for that was to bend the plate, right? So you bend the plate slightly, make it banana shaped, and then whenever you put the screw in and tighten it down, it sucks everything back down flat. Well, with this, you don't have to tune anything, because when you tighten the screw, it is self-tuning and applying the same force all the way around the perimeter. So everything is nice and flush. So yeah, V3 is the big improvement. I'll tell you what, let's go over to the computer, and I'll show you some of my CAD design that has gone into this. Oh, here's I think I set this one up with V3. You can hear the swish, but absolutely zero magnet rattle, right? Here's another hybrid I had set up earlier. Again, you can hear the swish, but there's absolutely no rattle, no magnet rattle whatsoever. That's the big thing with these. So if that was your hang up before, I think I've effectively eliminated that. All right, let's jump over to the computer for a minute, and I'll show you the CAD so it'll kind of make sense. We can do some section analysis views, and you can see what makes this happen, okay? All right, here we are at the computer. I've got a V3 plate here laid out next to a V2 plate. So the things that I was using to rigidize this plate were basically getting in the way for several reasons. The reason those were added was to add something to hold on to so I could machine this thing, and also add a center rib across this plate that I could use to keep it from having trouble maintaining some structural integrity, right? So this is good, and this is great, and for what I knew then, it's fantastic. It worked, and has worked for years now, right? I've gone to this realizing that the thinnest section of this plate is across this center right here, and it's in this orientation. So I was able to create a web on V3 that did not obstruct the center of the plate, did not go all the way across, and there's still plenty of integrity in the thickness of the material all the way around here. So if we throw a section analysis on this, we can look at how thick the plate is in certain areas. So if we measure, I'm not sure if we can measure a curve like that, but if we measure from there to there, let's see, yeah, it's not gonna do it. Let's do a plane, an offset plane, and go from here, and then we'll drag that down, let's say 10 thousandths. Let's see how that looks. Yeah, see, the plane is still just shy. So at the very edge of that web, see 12 thousandths, let's go 15 thousandths. Yeah, about 15 thousandths from the place here to there. In my experience, that's plenty. And if we look in this orientation, so let's throw a section analysis in this orientation. Give me a second. So here we are in a section analysis view of the opposite orientation, so 90 degrees compared to our previous view. And we can measure, let's see, turn those planes off, and let's measure from here. Let's go 0.01. That would be negative. There we go. Let's see, yeah, so about 10 thousandths from this point here down to here. It's also modeled very acutely. Like there is a 90 degree angle right here. In reality, there's a 15 thousandths fillet right here. So that actually reduces stress too. So we've been living with this entire time, if you look at a V2 plate right next door, it's identical in that orientation to this one because this center section is identical. So we've been living with 10 to 12 thousandths of material in this orientation for years now. So when we go and hop to this orientation, I'm still kind of overkilling it by having 15 thousandths. The point being is we have plenty of rigidity and we have plenty of stress reduction with the fillets that are machined in, that this should give absolutely no issues with breakage or anything like that. If that ever were the case, of course I would take care of it, but I do not see that happening, seeing as how we've been living with less material in this orientation for years now with the same amount of pressure. So let's throw it back in this view. Let's get this V2 plate out of here. Let's get rid of him. There we go. All right, now let's add a body. So this is just a blank body without any features on it whatsoever. This gives you an idea of how thin a Rapt actually could be. Like best case scenario, you didn't have any other machined features. The screw has plenty of room. So it doesn't have any breakthrough depth to it. So measure from there to there, about 185 thousandths, which is, 1875 would be 3/16 of an inch. So that's the absolute thinnest that we could ever get away with. But then of course you start adding features to that and it balloons in size very easily. So the point of this is to show that there is roughly, I believe that's 10 thousandths. It's either 10 or 15. I forget what the design spec on this was. We got 15 thousandths, as you can see there, 15 thousandths between here and here. So when all of the mating surfaces around the outside are connected, there's 15 thousandths of gap, which the center of this is moving up and pulling with it all of this material and creating additional concave area in the center. And then this is compressing the magnets and the insert and the foam. So let's throw a hybrid insert in there. Let's take that top off so you can see. So we have our insert in there. That's 125 thousandths or 1/8 of an inch. There will be magnets in there as well. Throw the top back on. And then we have a foam insert there as well, right? So let's add that foam insert right here. There it is. And then you can see that interference fit to where that foam has to expand to go around the post. That's what helps it hold so it doesn't fall off while you're trying to assemble it. It gives you that leeway to be able to assemble it and not have to worry about it after you throw it inside the body. Just as long as you're matching that insert with the type of magnet configuration that you're working with at the moment. So as you can see, there is 25 thousandths. So we measure from here to here That's not correct. That is not correct. From there to there. So that is the inside of the body to the top of the damper. That's 25 thousandths. So that's 25 thousandths of space. So that gives 25 thousandths of compressibility, and then we're only compressing by 15 thousandths. So you are compressing that foam by roughly, what would that be? That would be over 50%, right? I would say 2/3. So around 60% you're compressing that foam. I use a very hard foam that has a lot of compressibility, and it has a lot of resiliency, meaning that it will bounce back. So yeah, I'm pretty excited about this, guys. The people that like the rattle, you can still remove the foam and then throw whatever kind of, you could use the V2 rubber if you want to inside there. It doesn't matter. You can use whatever the heck you want to. If you're using foam though, it's going to compress it all together very uniformly, and it's going to lead to zero magnet rattle whatsoever. Another cool thing about this, I think this is my last point, is that it is fully backwards compatible. So you don't have to use a V3 plate on a body that's designed for a V3. I've designed it to be backwards compatible with V2 using a different screw. The reason we have to use a different screw is because the chamfers on the insides of the bodies here on the inner screw post, the chamfers were too small on a lot of the V2s that I made. So in order to compensate with that, I'm using a different type of screw. Let's see if I can find the screw here. Bear with me just a moment. All right, here we are back with the screw situation. This is the screw that I've used to be able to retrofit V2 to V3. So this is a Phillips drive screw, actually. And as you can see, the screw head is directly flush with the plate. And then the threads go all the way up to the bottom side of the plate, so that allows, even if it has a small chamfer, the screw threads are engaging through that chamfer, and then the plate is able to actually go up flush with the body. Now, I have updated my bodies to be able to accept the original screw, which would be this screw, the blue one. Let's take the red one off. And that's the screw that you know and love. But as you can see, this countersink engages the current size of chamfer. Let's throw V2 plate back in there. And when it seats, let's take the red screw out. That's not it. That's not it. V2. Nope. Oh, the wheels are falling off. I need to take that insert out. There we go. Let's take the foam out. Foam's done. What's in here? There it is. Take that foam out. There we go. Maybe that'll help. So V2 plate. Yeah, there we go. So you can see the counterbore that's there, and once that screw engages fully, let's move that screw about 10 thousandths. Yeah, as that screw fully engages, you can see how it is below the edges of that counterbore that exists on the V2 plate here. So with this other screw, let's see, take that other plate off. All this stuff runs together. There we go. Now you can see. With this new screw, there's plenty of thread length available to be able to suck that plate on up in there. So the moral of the story is, I know that was a long way to get to where we needed to go, but the moral of the story is, if you're using V3 plates on a V2 designed body, then you'll be using this Phillips head screw. And yes, it doesn't look as good as a Torx head screw, but hey, you're still able to use the updated plate on an older body. No huge deal. There does not exist a off-the-shelf Torx head screw with an undercut profile like this Phillips head screw. Now, there could be screws custom made, but there's no sense in adding cost to have a custom screw made. I just don't see any huge draw to having a screw custom made when they're made. They're basically the big failure point of the Rapt, and it's kind of a design failure point. And if I used a thicker, harder, custom made titanium screw, then I guarantee you we would have issues with stripped out threads and stuff like that all the time, and I do not want that to happen. So this is kind of the engineered failure point of the system. So like I said, V2 plate, you can use the original screw. V2 plate on a V2 body, you need to use the original screw. V3 plate on a V2 body, you need to use the Phillips head screw. V3 plate on one of the new designed V3 ready bodies, you'll use the new or the original, the actual original screw. So let's see, what other things are there to think about there? So on the, let's get that screw out of here. On the plate, let's see, let's take the plate off. Take that plate off, there we go. So on the inside of the body, when I laser these, any of the ones that are in the that are updated to accept V3, there will be a little asterisk under the name and the serial number and all that. There's going to be an asterisk there. If there's an asterisk on your body that you receive from me in the next few months or whenever, if there's an asterisk there, then it is V3 ready. So there you go. All right, let's flip back around. I'm gonna go ahead and apologize for my long-winded ramblings, but I guess I'm just gonna leave it all in there. I think I explained everything to the best of my ability. I can't think of anything that I left out. The sign-up sale items for this week are bronze SSSs, just machine finish. There's gonna be 10 of those. So they will all be V3 compatible, and they will ship with V3 plates. So it's a new thing. We're going to go ahead and get the ball rolling here and get those out to you, or to the winners of the sign-up sale. So yeah, from here on out, it's all going to be V3 bodies, all going to be V3 plates. I have been reluctant to add additional stock to the website of the V2. So of the V2 inserts, what I have is what I have, and I don't plan to order anymore unless there's some public outcry saying that they want this that's been out of stock for X amount of days or blah blah blah. That'll be fine. We can work through that. V2 compatible. I mean V2 inserts are compatible with V3 plates. That's great. What else? All the damper materials and everything that you currently own are all compatible. When I sell the V3 plates separately, I can offer a package that includes screws. And then I'll, of course, post all this information up in a good spot to where everybody can find that info easily. What else? I'll probably eventually will do metal inserts for V3. I feel really good about it. And I think that the magnet rattle issue that we have with brass inserts, that's going to be completely mitigated. So that's another positive. This is just overall just a great product enhancement. I'm pretty pumped about it. So yeah, let me get busy. I'll get some sign-up sale stuff posted up today. And yeah, let me know if you have any questions. You can reply here. I think I'm going to post this on both YouTube and on the Facebook group. I may just do YouTube and then link it through the Facebook group. I think that'll be best. So, all right. Everybody have a great day. Have a fantastic weekend. It's Friday, October 4th. Everybody have a great weekend, and we'll talk to you later. Thanks. Bye. All right, here we are at the bench. So new parts, a whole new, it's really, I mean, I keep saying new, it is new, in that let's delete